Hello guys, welcome back to a new video. In this video we'll be starting chapter 2. Chapter 2 is about strength of solids. Now we have section 1, phases of matter and forces among their molecules. Now if you take a good look around yourself, you can see many objects, okay? You can see the device that you're using to watch this video. You can see your pen, your notebook, your bag, the door, the walls, okay? All of these are what? They have something in common, which is that they are all made of matter, okay? And matter can be classified into 4 phases, okay? What is a phase? Any of the 4 states of matter. You have solids, liquids, gases, or plasma, okay? Now, solids, before we talk about other things, let's talk about their atomic arrangement. The distance between the molecules or the atoms of solids is that they have a very small distance between them, okay? This closeness of their atoms gives them definite shape. Remember, definite shape and definite volume. What do you mean by definite? Definite means fixed, okay? Means that their shape or volume does not change, okay? So an example of it can be what? A rock. A rock is an example of a solid, okay? Rock is a solid object. Its shape does not change if you throw it, if you give it to someone else. Its volume also does not change. Something really important you should know is that atoms in solid are closely packed and they have a regular shape. You see that the atoms have a regular shape. They don't have a random arrangement, okay? The closeness of atoms in solid gives them high density. So the density of the rock is really high. Density is high, okay? But if you have a rock, try to squeeze the rock, okay? Try to compress the rock. Can you make it smaller and compress it? No. So solids have what? Have low compressibility, okay? Cannot be compressed, okay? Now, we have liquids. The atoms of liquids are also close together, okay? But the difference between solids is that they don't have a regular shape, okay? This irregular arrangement of atoms of solids gives them the ability of flowing. For example, you have water, which is flowing. You have juice, milk. All of these are what? They can flow and they can move, okay? Liquids, they have no definite shape. So they take, for example, you have this glass, okay? It takes the shape of what? It takes the shape of the container, okay? So liquids, no definite shape. But they have what? They have no definite shape and they have a definite volume, okay? Definite volume. Imagine you have 2 glasses. One of them is empty and the other one is filled. Now pour the water from the filled one to the empty one. Does the volume of the water change? No, it doesn't, okay? So they have what? A definite volume. Like solids, the density of liquids is high too, but compared to solids, it's less, okay? So solids, remember, they have the highest density. Liquids, they cannot be compressed too. If I ask you why, you'll say because the distance between the atoms is too small, okay? Now you have gases. Gases, they have no shape or volume. Sorry, no definite shape. Okay, no fixed shape. No definite shape or volume. You have a balloon, okay? You have inflated the balloon, let's say with helium or with using your mouth, okay? So if you squeeze this balloon, you can see that the shape of the balloon is going to change. So it doesn't have any shape, okay? It doesn't have any definite shape. Also, the volume is going to change. You can squeeze the balloon very easily. So this gives, we can conclude from that because the distance of between the atoms of gases is really high, it's too great, it gives the property of not having any shape, not having any definite shape to gases, okay? And it gives them something else. They have the lowest density, careful, gases, they have the lowest density, but they have the highest compressibility. Remember the example of a balloon. You can squeeze the balloon very easily. Why? Because there is a gas in the balloon, okay? And the distance between the atoms is high, so you can compress them very easily. You have a ball, okay? Inside a ball there is what? There is a gas, okay? You can compress the ball very easily. A tennis ball or any other ball. You have the fourth state, which is what? Plasma. Plasma is the fourth state, and it's achieved at extreme temperatures, okay, meaning very, very high temperatures. It basically happens when the atomic nuclei and the electrons are moving very, very fast, okay? You have three examples of plasma. You have aurora. You might have seen this in movies or any other worlds, okay? You have lightning, which is what? Which is in the state of plasma. And you have stars. Most importantly, stars are what? Are in the state of plasma. The phase of stars is what? Is plasma. And since the mass of the universe is mostly concentrated in stars, so most of the universe is what? Is in a state of plasma phase, okay? If I ask you why, because you'll say most of the universe's mass is concentrated in stars, and 90% of all the matter in the universe is what? Is in plasma. So I'll repeat, you have three phases, solids, basically have three phases, but we don't mention plasma always, just we briefly talked about it. You have solids, liquid, and gases. Solids, they have a definite shape and a definite volume. They have the highest density, but they have the lowest compressibility. They cannot be compressed easily. Liquids, they have no definite shape, but they have a definite volume. Gases, they have no definite shape or a volume. They can be compressed easily, and they have the lowest density. So if I can draw this here, density of solids, okay, this is density of solids, is greater than density of liquids, and density of liquids is greater than density of gas. So you have gas, liquid, and solids. Solids have what? The highest density. Highest density, gases, they have the lowest density. But careful, gases, they have the highest compressibility. Solids, they have the lowest compressibility. How can we change the phase of a material? How can we transform one material from one phase to another? Very simply, by giving thermal energy. For example, let's say you have a cup of water. Let's just draw it. Let's say you have a cup of water. Or let's say you have a pot of water, okay? How can you change the phase of this water? Very simply, by giving what? By giving thermal energy. By thermal energy, you mean, and we said it with thermodynamics. It was about heat and temperature. So you can give what? Heat, okay? basically we mean when you talk about thermal energy, we mean heat. Okay, so if you give heat, if you put this on a stove, and you have ice, let's say you have ice in here, so this is going to what? This is going to melt, and it's going to change its phase from solid to liquid and then to gases. Another way of changing this is by giving mechanical energy. What do you mean by mechanical energy? I'm sure you have all drinking tea or any other drinks. If you put ice in it, okay, let's say, or if you put sugar in it, if you stir the tea, you can see that the sugar melts faster. Why? Because you are giving the liquid or the sugar some mechanical energy. Okay, by mechanical energy we mean kinetic energy. Okay, kinetic energy. Okay, so when you give or you stir or you shake the liquid, it's going to what? It's going to make the process of melting faster, and this you have what? You will change the phase from one to another. Okay, let's say from solids to liquids or from liquids to gases. So how can you change fast? How can you change the phase of a matter from one phase to another? You'll say by what? By giving mechanical or thermal energy. Okay, we have temperature, by changing its temperature, or by pressure. Okay, by changing the pressure of an object. Now we will be talking about the molecular structure of matter. When we are dealing with the molecular structure of matter, we have certain terms you should remember. You have mole. Okay, mole is the amount of mass that contains as many entities as there are in a 0.012 kilogram of carbon. I'll explain this very briefly. Let's say you have 0.012 kilogram of carbon. Okay, this is what? Carbon 12, C 12. Okay, this is carbon 12. It says containing as many entities as there are. Entities means you mean atoms, okay, or particles. Okay, let's say particles. Okay, it's better. Particles. Now, if this is a 0.012 kilogram of carbon, we are going to measure how many entities we have here. Okay, how many entities we have here. Okay, we are going to count each one of them. Okay, and this is going to be called what? This is going to be called 1 mole. Okay, 1 mole, guys, is equal to 6.02 times 10 to the power of 23 mole inverse. Okay, so 1 mole contains basically 6.02 times 10 to the power of 23 entities. Okay, atomic mass is what? Atomic mass is the 1/12 of the mass of a single carbon of carbon 12. Its value in its is 1 U, which is equal to 1.66 times 10 to the power minus 27 kilogram. The molar mass is the mass. We will be learning this in the next lesson. You don't have to worry about them. Forces holding matter together. This is the difference between solids, liquids, and gases. In solids, particles are closely bound or closely packed. In liquids, particles are close to each other, but not as much as solids. Particles are much far apart compared to solids and liquids. Okay, so careful, this is really important. This is the difference between all the three. Fixed shape in solids, no fixed shape in liquids. They take the shape of the container. No fixed shape, gases, careful, they also take the shape, or they fill in the entire space they're closed in. Okay, they don't have a shape, but they fill the entire space. For example, if you have a perfume, spray the perfume and you'll see it will fill the entire room. Solids, they have fixed volume. Liquids, they have fixed volume. Just gases, they don't have any fixed volume. Solids, they cannot flow. Liquids can, and also gases can flow too. Solids, they maintain they form and occupy only as much space, don't fill the completely as they have greater density than gases. Okay, fill the container fully due to their low density. Okay, most importantly here, solids cannot be compressed, liquids cannot be compressed easily as the particles are relatively close. Gases can be compressed easily as they have what? As they have low density. A question: why is it difficult to compress solids? Because the particles are close together. Why is it easy to compress gases? Because the particles are loosely packed together. Now you have this graph here, this one, this line graph. I'll just simply explain it for you. It's really easy. The graph is a little bit difficult to understand, but just pay attention. I will explain this and it will be much easier. Now, imagine you have two atoms. You have two atoms, okay? Let's say atom A and atom B, okay? Between any two atoms of a substance, there is a force of attraction and repulsion, okay? Now, if you know atoms, they have nucleus and they have electron too. Electron, guys, makes a cloud-like something. Let me draw this better. Electron makes a cloud-like, the electron is a cloud, okay? We call this what? Electronic cloud, okay? So this atom cannot cross the electronic cloud of this atom, okay? Atom A cannot cross the electronic cloud of what? Of atom B, okay? If the distance between them, guys, let's call it the limit, okay? This is the limit that they should not be crossing, okay? We call this R naught, okay? R naught. R naught is what? It is equilibrium distance. Equilibrium distance, okay? This is the distance the atoms that can't cross, okay? This is the distance that atoms cannot be crossing, okay? They should not cross this distance. The real distance between the two atoms is called R, okay? R, okay, is called what? It is called distance, R. This is distance between the two atoms. Look, guys, if this R becomes too great, okay, if this R becomes too great, the force, let's say this R here, this one, becomes too great, the distance between them becomes too great, it becomes greater than the equilibrium distance, okay? Look, this is R, it became greater, okay? The force among these two atoms is going to be what? It's going to be attractive, okay? So these atoms are going to attract each other, okay? Oppositely, if the distance between these two atoms becomes less than the equilibrium distance, so you see, the electronic clouds are now what? Are now crossing each other. So let's say this is R, okay? Now, so the force between them will be what? Will be repulsive, okay? The atoms are going to what? Are going to repel each other. If the distance is just right, okay, like let's say this, it's like this. So R is equal to R naught, then this is called equilibrium state. This is here, I'll explain again. If you have two atoms, okay, let's say this is the equilibrium distance between them, R naught. If the distance between the atoms, which is R, is less than the equilibrium distance, okay, equilibrium distance is what? Is R naught. The force will be repulsive, okay? This is the equilibrium distance. The two atoms now have crossed this equilibrium distance, and now they are too close. So the force among them will be what? Will be repulsive. If the distance between two atoms, which is r, is greater than the equilibrium distance, r naught, the force will be what? Will be attractive. So you see here, this is the equilibrium distance. Now the r is too great, okay? The distance between the atoms is greater than the equilibrium distance. Here, the force will be what? Will be attractive. If r naught and r are equal to each other, then the force will be what? The two atoms will be in a state of equilibrium and there will be no repulsion or attraction. We have bonds. A bond is a force leading to the attraction of the atoms, okay? We have three types of bonds. We have ionic, the first one. So ionic bond, guys, let me explain all this. You have three bonds. You have ionic bonding. Ionic bonding happens when an atom of an element shares an electron with another atom, okay? So you have what? You have donating and you have receiving of electrons, okay? Now, an example of this can be what? Can be NaCl. NaCl. The atomic number for Na is 11, okay? The atomic number for Cl is 17. Let's make the atomic configuration and it will be much easier to understand, okay? Let's say this one is what? First one, Na. You have Na. You have how many electrons? You have 11. So you have the first shell, which is filled with 2 electrons. You have the second shell, which is filled with 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. So how many electrons now I have? I have 10. Okay, so 2 here, 2 in the first shell, and 8 in the second shell. In the third shell, I have only 1 electron. I have only 1 electron. Okay, so this is the third shell. In the third shell, I only have 1 electron. This is for what? This atomic configuration of sodium. Now we have Cl. For Cl, we have 17. Okay, Cl. You have 17 electrons. In the first shell, you have 2 electrons. In the second shell, you have 8 electrons. So 1, 2, 3, 4, 5, 6, 7, and 8. This is 10. And you have 7 in the outer shell. In the last shell, 1, 2, 3, 4, 5, 6, and now this is 7. Now you have how many electrons? You have 17 electrons. Now look, guys. We said that ionic bonding is about what? Is about sharing electrons. As you can see here, guys, NaCl is salt, by the way. As you can see here, this last electron here, okay, this last electron here is going to fill the last shell of Cl. So this electron is going to move here, and this one will be what? This one will be filled. And Na is going to donate an electron to Cl. So Na is going to be what? Is going to be positive, and Cl is going to be negative. So you have negative ion and positive ion. I'll repeat this. Na has 11 electrons. It has one electron in its third shell, and it's going to donate it to Cl. And now Cl is filled, okay, the last shell is filled, and there is the donation and receiving of electrons. This is called, whenever there is donation or receiving electrons, it's called ionic bonding. You have covalent bonding. Let's do it here. You have covalent bonding. Covalent, the second one is called covalent bonding. Covalent bonding, an example of it is what is oxygen. Now oxygen has how many atomic numbers? It has 8 atomic numbers. Now let's do the atomic configuration. You have oxygen. In the first shell you have 2 electrons. In the last shell, because we have 8, you have only 6 electrons. So you have 1, 2, 3. Sorry. You have 1, 2, like this. 1, 2, 3, 4, 5, 6. And you have another oxygen. 1, 2, and the last shell. 1, 2, 3, 4, 5, 6. Now look guys, in covalent bond, the electrons are going to what? Are not going to donate, or the atoms are not going to receive or donate an electron. As you can see, you have oxygen. Can it donate this electron to this one? No, because its shell is not going to be filled, and this one is not going to be filled too. It needs 2 electrons to be filled. What can they do? They'll decide to what? They'll decide to share these 2 electrons, okay? So this is what? Sharing, okay? Covalent bond is about what? Is about sharing electrons. Sharing electrons. An important note, and you have a question in chapter review 2, which one is stronger, ionic or covalent bonding? Of course, ionic bonding is stronger because when an atom receives and the other one donates, there is a strong attraction force between the negative and the positive charges. That's why ionic bond is much stronger than covalent bond. You have the last one, which is metallic bond. Okay, metallic bond is a bond that only happens in metals. Okay, for example, let's say lead, or which has an atomic number of 82, or Cu, which is copper, which has an atomic number of 29. All of these have one. So if you do the atomic configuration for Cu, you can do it, but its last shell, its outermost shell, is going to have what? Is going to have an electron. Okay, all the atoms of copper are going to what? Are going to let this electron flow freely. So as you can see here, these are atoms. The electrons is going to what? Is going to swim in a sea of electrons. For example, you have copper, which is used in electricity because the electrons can move freely, okay? So in a metallic bond, you have a free negative electron moving freely among the atoms, okay? Now, let me repeat this. You have 3 bonds. You have ionic bonding, which happens by donating and receiving. You have covalent bond, which happens by sharing. An example of it is oxygen. An example for ionic is NaCl, crystals of sodium chloride. You have metallic bonding, which only happens in metals. You can just know it by its name, metallic in metals. This is it for today. See you in